packaging material using recycled fibers and unbleached subabul sapwood pulp through nanotechnology. In this research, we used fresh wood pulp of subabul sapwood and recycled Amazon packing soaked pulp in 50-50 ratio for 48 hours. The refining was carried out for the mixed pulp by using supermass collider and lab valley beater. Later, the sheets were fabricated by using hand sheet former, and the burst test, microscopy and porosity tests was carried out on these sheets. From this, SMC refined sheet got high burst strength and low porosity compared to LVB sheets. From this, we are concluding these sheets can be used in food packaging applications. In this picture, we can explore micro and nano cellulose fibers which are in the 100 to 3000 nanometers range. Nanocellulose have high surface area, high aspect ratio, and these are biodegradable in nature. Nanocellulose can be used in wide variety of applications. Here mainly we are focusing on paper and packaging. This is the methodology which I already explained. Coming to lab valley beater refining, this lab valley beater works on the principle of cutting, impact and shear forces rupturing the cell wall. This consists of rotating beater roll and fixed bed plate. When the pulp is moving between the beater roll and beater plate by reducing the weight, by applying weight of 5.5 kgs, we can decrease the gap between the beater roll and beater plate. Then fiber cutting will happen. From this we are getting most of the microcellulose. This is LVB refined pulp slurry. Next one is supermass collider refining. Supermass collider is inclined towards the outlet because the easy flow of the product. In this process, we started at 1 mm clearance, then we reduced the gap to 0.4, 0.1, 0.01 by using dial gauge. This refining was carried out for 15 minutes for all intervals. Later we reduced the gap to zero clearance. In zero clearance we will get the most of the nanocellulose. By decreasing clearance, the pulp consistence should be decreased because the wet slurry should be there while grinders are coming to close. And the vortex formation is happening at the zero clearance. This was reduced by using the baffle. This is SMC refined pulp slurry. These are the grinders present below the hopper. One is rotating and one is stationary. These are the grooves which are responsible for the diameter reduction of fibers. And this is the grinding zone where the grinding will take place. This grinding happened at the 1000 RPM. Later, the sheets were fabricated by using LVB and SMC refined pulp slurries. Here we took 1000 ml of pulp slurry, then we poured into this cylindrical container, one metal filter and one Wattman filter or metal filter is present in the handsheet former. We used extra 10 micropores of Wattman filter for the retention of nanocellulose fibers. After releasing pressure valve, the filtration will take place. The micro and nanocellulose sheet were fabricated. Later, the vacuum is applied to remove the excess water. This is the sheet after filtration. Then we did the heavy rolling on the sheet to remove the unbound moisture from the sheet. Later, the sheets were dried in the humidity chamber at 60 degrees centigrade for 2 hours. These are the dryer plates where the convection heat drying takes place. Later, the morphology of the SMC and LVB sheets were checked through the scanning electron microscopy. Picture A showing the SMC refined sheet, and picture B explains about the LVB refined sheets. Most of the nanocellulose in the range of 60 to 260 nanometers in SMC refined sheet. LVB refined sheet contain 1 to 5 micron size. LVB sheet also consists of nanofibrils, but these have less aspect ratio compared to the SMC refined sheet. The next one is burst strength. Burst strength is where the maximum pressure at given component can withstand before it bursts or fails under pressure. In this process, we are using 3 mm stainless steel probe with a contact area of 7.07 mm square with a test speed of 0.5 mm per second, the target distance of 5 mm. The blue line indicating the SMC refined sheet and the red line indicating the LVB refined sheet. SMC refined sheet showing the high burst strength compared to the LVB sheet because LVB sheet contains more amount of nano and microcellulose fibers which showing the ductility in nature. LVBs have brittle in nature. By same images we can observe the fractures. The next one is porosity test. Porosity measures the amount of time required to pass through certain volume of air through the test specimen. In this process we used 4 different sheets. 2 is made by LVB and SMC refined sheet, 2 are commercially available sheets. Commercially available sheets have thin plastic wrap on the sheets. We remove the thin plastic wrap, then we check the porosity, but we are unable to remove the full plastic wrap on the green paper plate and the coating with fragmented aluminum wrap on the aluminum paper plate. This aluminum sheet is very less thickness compared to all. From these results we can understood that by increasing amount of volume of air, the time taken is increasing. SMC 0 sheet and green comparison with green paper plate, it's nearly showing equal amount of time to pass through 300 ml of air. Green paper plate have less thickness but with plastic wrap. SMC sheet have little more thickness than the green paper plate which doesn't have any plastic wrap or coating. From this we want to mimic the green paper plate with SMC sheet. We can reduce the thickness of the SMC sheet, then also we can obtain the less time. These are the microscopic images of commercial paper plates which are containing the aluminum coated paper and thin plastic wraps. These are LVB and SMC refined sheet which doesn't have any coating or thin plastic wrap. From this, we are concluding that SMC refined sheet have high burst strength, low porosity, and these nanocellulose fibers are in the range of 60 to 260 nanometers. By producing nanocellulose from the recycled fibers like Amazon, by using supermass collider we can eliminate the non-biodegradable plastic materials which are used in present commercial paper plates in food packaging industry. By using this supermass collider sheet we can retain more amount of water for long time also. Thank you. These are the commercially used paper plates which have thin plastic wrap. We can eliminate that one. These are which don't have the plastic wrap on the biodegradable plates, but this contains polyfluoro alkyl substances which are not, it will go into soil and it will contaminate the underground drinking water systems and so many health effects and to humans and aquatic systems to happen. From this We can, by using nano cellulose, applying on top of the coating layer as layer on the sheet, we can strengthen the paper plate. Thank you.